Okay, so we are to the third lesson in Unit 4. And in this lesson, we're shifting from the graphing side of things to solving quadratic equations. And the first method we're going to learn to solve quadratic equations with is factoring. So I'm going to show you how to factor, which is something we covered shortly in Algebra 1, but I understand that's a couple years ago. So the vocabulary is just to get you comfortable with monomial, meaning one term, binomial, 2 terms, trinomial, 3 terms. Quadratic equations is what we're going to solve today. And then roots, zeros, solutions, they all really mean similar things. We are going to be finding solutions today, okay? So in order to find solutions, we're going to have to know how to factor. So to factor this expression, x squared plus 7x minus 8, I'm going to use kind of a pattern, and I gave you some kind of warm-up problems with this type of puzzle. And basically, you're taking the b term and the c term in this quadratic. I'm going to put the c term at the top, negative 8, and the b term at the bottom, positive 7. And to factor, what I am looking to do is I'm looking to find two numbers that multiply to be negative 8 and add to be 7. So these numbers, if they multiply to be negative 8, that means one has to be positive, one has to be negative. So you should be able to do some of these in your head, but you may want to list the factors of 8. So the factors of 8 would be like 1 and 8, 2 and 4, and that's it. So I'm looking which pair of these would add to equal 7. Well, I would think positive 8 and negative 1 would do the trick, because 8 plus negative 1 is 7, and 8 times negative 1 is negative 8. So when I go back to factor this, the way I would write this in factored form would be x plus 8 times x minus 1. So this is kind of like we talked about double distribution before. This is undoing that. So we are finding numbers that add to be the middle term and multiply to be the last term. Okay? So that's why this little puzzle, this little pattern on the side, I think helps nail that down a little bit. So in example 2, factoring with a special pattern, we're going to do the same method. Numbers that multiply to be negative 25, but there is no b term. There is no middle term. So what I would say the middle term is just 0. So then I'd think to myself, numbers that add to be 0 and multiply to be negative 25. Well, again, they multiply to be negative 25, meaning one has to be positive, one has to be negative. And my factors of 25 are just 1 and 25, which wouldn't get the job done, and then 5 and 5, which should make sense. 5 and negative 5. 5 times negative 5 is negative 25. 5 plus negative 5 is 0. So the way I'd write this in factored form is x plus 5 times x minus 5. Now, if I wrote x minus 5 times x plus 5, that's the same thing. The order does not matter in multiplication, but it's important that I know this first 5 stands for plus 5, this one stands for minus 5. So the special pattern there is that we had 25. 25 is a perfect square, so we know these two numbers would be the same. Okay. For part B in this example, we are looking for numbers that multiply to be 121 and add to be negative 22. So again, we look at this, multiply to be 121, add to be negative 22. Well, in my brain, I'm thinking both numbers have to be negative, because a negative plus a negative is negative, and a negative times a negative is a positive. So in this is a perfect square. The two numbers, negative 11 and negative 11, because negative 11 times itself would be 121. So I would write this as x minus 11 times x minus 11, which really is x minus 11 squared. So that is factored completely. That is as far as I can go. But just remembering, numbers that add to be the middle term and multiply to be the last term. Takes a little bit of practice to get used to how to factor these. So I'm going to give you some practice with factoring, and once you get that down, the solving isn't far behind. So we're going to use something called the zero product property. And in simplest terms, as I can explain it, is this: if the product of two expressions is 0, then one or both equals 0. So if I multiply two numbers and the result is 0, either one has to be 0 or both have to be 0. So at least one of the numbers has to be 0 if their product is 0. So in example 3, we are still doing the factoring. I'm going to factor this. Negative 15, negative 2, my two numbers, negative 5, positive 3. So writing this equation out in factored form would be x minus 5 times x plus 3 equals 0. So what I'm looking for is I'm looking for the value of x that makes either of these factors 0. So I'm looking for the value that makes x minus 5 0. I'm looking for the value that makes x plus 3 0. And after a while, you can just use mental math to figure this out. But my solutions to this, the values that make each factor 0, one solution is 5, positive 5. The other one is negative 3. Because 5 minus 5 is 0, negative 3 plus 3 is also 0. So that's why those two numbers are my solutions. It's the opposite value, okay, the opposite sign. So example 4. In example 3, we found the roots. We already had this set equal to 0. In example 4, we've got y equals. So we've got a function. All I have to do to find the zeros of this function is I've got to take my expression, x squared plus 5x minus 6, and set it equal to 0. We are finding what values of x make the y values of this function 0. We are looking for actually the x-intercepts of this graph, if we're thinking about it graphically. So, another factoring. Numbers that multiply to be negative 6 add to be positive 5. So when we think about that, one has to be positive, one has to be negative. So I'm going to think 6 and negative 1, because 6 minus 1 is 5. So my factored form, x plus 6, x minus 1 equals 0. And if you're using mental math, the value that makes this first factor 0 is negative 6. The value that makes the second factor 0 is positive 1. So those are my two solutions, my two zeros of that function. Okay, so that's the idea, is we factor, and then we figure out which values make each factor 0. So I'm going to give you a chance to do the guided practice. Good chance for you to try these out, try to look at the previous examples to help you practice it, and then once I explain through these, I'm going to have you move on to the actual practice, which is most likely going to be some online version. If you would like to do paper and pencil practice, I can still count that as your grade. If you want to do that instead, you just have to send me a picture of your work for me to count that for you. Okay? So pause the video, work through these, and then check your solutions with me when you are ready. Okay, so real quick, my solutions to the guided practice. The factoring, numbers that multiply to be 2 add to be negative 3. I've got negative 1 and negative 2. So what values make those factors 0? Positive 1 and positive 2. For the second one, I take my expression, set it equal to 0, and then I factor the same way we've been factoring. Numbers that multiply to be negative 40 add to be 3. That's going to be positive 8, negative 5. So this is what it looks like in factored form. So for my solutions, I'm finding out the values that make these factors each 0. So my solutions, 5 and negative 8. Okay, so that is how we use factoring to solve some of these quadratic equations. So this is a good chance for you to get some practice, reference your notes, ask for help, and then once you're ready, you can do the checkpoint in order to move on to lesson 4. And after lesson 4, you're going to take the first half of Unit 4's quiz. So I'll have some review materials for you for that.